Hi everyone, and welcome to our video where we will be looking at some exam questions on the Group 1, 7 and 0 elements from the periodic table. So if we have a look at this first question, it says this question is about groups in the periodic table. The elements in Group 1 become more reactive going down the group. Rubidium is below potassium and they are both added to water. Predict one observation you would see to show that rubidium is more reactive than potassium. Now, an exam technique that you can see over here, you need to show that rubidium is more reactive than potassium. So if you say fizzing or bubbling, that won't be enough. You have to say that rubidium will fizz more than potassium, or you will see a brighter flame with rubidium than potassium. You would see more bubbles, more of a vigorous reaction with rubidium compared to potassium, because you are showing not just an observation, you are showing how that observation proves that rubidium is more reactive than potassium. So if we have a look at the mark scheme, it says more vigorous bubbling for rubidium. You need the more, okay, because that shows that rubidium is much more reactive than potassium. Or you have to say that it has a bigger or brighter flame than potassium for rubidium. And again, for the other options that you could have had, you can see catches fire more quickly, moves around more quickly, explodes, because potassium doesn't explode, disappears more quickly, and melts more quickly. So as you can see, all of them are comparative statements. You are saying how rubidium is more reactive than potassium in an observation format. Okay, so just a bit of an exam technique that you could use for future questions that you answer. Next question, it says explain why rubidium is more reactive than potassium. So we know that rubidium is more reactive than potassium, but why is it more reactive than potassium? That's what we need to say. Now, rubidium, when we look at group 1, is lower down in the group compared to potassium. What does this mean? Well, what are all metals reacting to do? They all have one electron in their outer energy level. All of group 1 have one electron in their outer energy level. And their aim is to lose that one electron, so they now have a full outer energy level. So rubidium is going to try lose the electron. Now, when you move down group 1, there are more and more electron shells which come into the atom, okay? And the outer shell electrons which are placed in the atom, they are more weakly attracted to the nucleus, which means that they are easily lost, okay? So for example, potassium, let's say this is the nucleus, may have this many electron energy levels. Rubidium, because it has more electrons, it will have much more electron energy levels like that. And the outer electron will be placed in the outer shell of the electron energy levels. And as you can see with rubidium, it will be more distantly placed compared to the potassium. Okay, over here you will have a stronger attraction, whilst over here you will have a weaker attraction, which means that in rubidium, this electron will be lost much more easily. Okay, and it will react much more easily because there is that weaker attraction. And that's what we want for a group 1 element. We want there to be a weaker attraction so it can react with something else and have a full outer energy level. That's why rubidium is more reactive than potassium. It has a weaker attraction between the nucleus and the outer shell electron, which means the outer shell electron is more easily lost, and rubidium can go react with something else very quickly because it's very weakly attracted to the outer shell electron. Whereas with potassium, there is a stronger attraction, which means that the nucleus is going to try hold on to that electron instead of just letting it go. So putting up the mark scheme definition, again, this is a very common exam question. So it's worth putting this onto a flashcard or just memorizing the mark scheme because you can learn where the individual marks are coming from in a question like this. Normally, you understand what's going on, but students normally struggle to put it into words. So it says rubidium's outer shell electron is further from the nucleus. That's the first mark. Okay, because rubidium, it has more electron shells because as you move down group 1, the number of electron shells increase. So the outer shell electron is further placed from the nucleus. This means there is a weaker attraction between the nucleus and the outer shell electron. That's where your second mark is coming from. So the first mark, distance, second mark, attraction, and then the third mark is from making the conclusion that because there is a weaker attraction, that electron is more easily lost. Okay, so that's your 3-mark breakdown, and this will come up very likely on your paper, maybe with different elements. Okay, so it's worth learning the format of the answer that you would need to provide for 3 marks. Okay, so moving on to our next question. It says complete the equation for the reaction of rubidium with water. So we've got group 1 metal and it's reacting with water. When it reacts with water, it will form a metal hydroxide and hydrogen. Okay, so hydroxide is OH. So remember the hydroxide ion is OH minus. Rubidium, when it reacts with something, because it's in group 1, it will have a positive charge, positive 1 charge. And as you can see, the charge is balanced. So the formula that you're looking for is RbOH, rubidium hydroxide, and you will also produce hydrogen as a product when you've reacted it with water. Now it's 3 marks. You need to balance this equation. Rubidiums are balanced on either side. Oxygens are balanced on either side. However, the hydrogens are not balanced on either side. On the left, on the reactant side, we have 2 hydrogens. On the product side, we have 3 hydrogens. So to make that an even number, let's add a big 2 in front over here. And that means on the product side, we now have 4 hydrogens. And on the reactant side, we only have 2 hydrogens. So we can add a big 2 in front of here. So that means we have an equal number of hydrogens on both sides. We have 4 hydrogens on the reactant and we have 4 hydrogens on the product. However, we also have 2 rubidiums on the product side because we added it a big 2 over here. There are 2 rubidiums. So we're going to have a big 2 in front of there. So that means there are 2 rubidiums on both sides. There are 2 oxygens on both sides and there are 4 hydrogens on each side. Everything is balanced. That's how you would balance the equation. Okay, so as you can see, 2Rb plus 2H2O produces 2RbOH plus H2. Ignore state symbols. You just need to get the correct products and you need to balance it for 3 marks. Okay, moving on. This time we've got a question about the noble gases. It says, which is the correct statement about the noble gases? The noble gases all have atoms with 8 electrons in the outer shell. The noble gases have boiling points that increase going down the group. The noble gases have molecules with 2 atoms. The noble gases react with metals to form ionic compounds. Okay, so if we go through the process of elimination, many people get confused with that first point and they opt for the first option in that list, that they all have 8 electrons in the outer shell. Okay, now that's not true because the first element at the top of the group only has 2 electrons in its outer shell because it can only hold a maximum of 2 electrons. Okay, helium can only hold 2 electrons. It only has 2 electrons, which means that in its outer shell, it only has 2 electrons. So it's not going to be the first option. Now, the correct answer to this is actually the second option. This is just a fact that you need to learn, that the noble gases have boiling points that increase when you go down the group. So as you move down the group, the boiling points of the noble gases increase. And that can come up as an application question as well, where you're asked to predict the boiling point of a certain noble gas. If you remember that key point, that as you move down the group, the boiling points increase, you won't be going wrong with that question. The noble gases have molecules with 2 atoms. That's just not true. It's the halides which have diatomic molecules. The noble gases react with metals to form ionic compounds. Well, they don't, because the noble gases are noble because they are very unreactive, because they are already very stable. They have a full outer energy level, so they don't need to react anything, and they certainly don't form ionic compounds. Okay, so it says the noble gases have boiling points that increase going down the group. That's the correct answer. Okay, moving on. It says table 2 shows observations made when lithium, potassium and rubidium react with water. So you've got lithium, it says bubbles, slowly, floats, moves slowly. Sodium, we need to fill in the two options. Potassium, bubbles very quickly, melts into a ball, floats, moves very quickly, flame. And then rubidium sinks, melts into a ball, explodes with a flame. Now, apart from this question, it's worth noting this table down just in your notes, because if you're ever asked a question about the observations, you can always use these as your observations. Okay, and because they've been mentioned in an exam question, they will also be present in a mock scheme if you get asked a question like this. So it says give two observations you could make when sodium reacts with water. Write your answers in table 2. Now the key to this is again looking at the exam technique that we looked at in the first question of this video. When you are comparing the group 1 metals, as you move down, the reactions get more and more vigorous. So when you're looking at observations, you have to make a comparative observation. So lithium bubbles slowly. That means that sodium is going to bubble quickly. If lithium moves slowly, that means sodium is going to move quickly. And then when you look at potassium, it says bubbles very quickly and moves very quickly. So as you can see, as you're moving down group 1, the observations get even more vigorous. So it says any two from the following: bubbles quickly. So as you can see over here was bubbles slowly. Over here it's going to be bubbles quickly. And then in potassium it goes bubbles very quickly. You could say melts. You could say floats. And you can say moves very quickly. So over here it said moves slowly. And potassium says moves very quickly. Sodium can be moves very quickly because the strength of the reaction is increasing, because there is more shielding, there are more electron energy levels which are coming about as you move down the group. Then it says, how does the reactivity of the elements change going down group 1? And as we've mentioned already, as you move down group 1, the reactivity of the elements increases. Okay, so there's where your marks are coming from in these two parts of the question. Okay, so final question, it says explain why the reactivity of the halogens decreases going down the group. So we've looked at group 1 and group 0 briefly. Looking at the halogens, in terms of reactivity, what is happening in terms of the halogens? So this is the complete opposite of group 1. Many people get confused with the wording that they are meant to use. When do they use shielding? When do they use attraction? All that sort of stuff. When do they use it for what questions? Okay, so the questions that you use it for varies. And the key difference is between the group 1 metals and the halogens. In halogens, they all have 7 electrons in their outer energy level. So they don't want to lose electrons to have a full outer energy level. They want to gain 1 electron because that's much easier. They can either lose all 7 electrons and have a full outer energy level, or they can just gain 1 electron and be happy and have a full outer energy level. So the halogens, they're going to be aiming to gain 1 electron. To gain 1 electron, they need to attract that electron. But if you move down the halogens, there are more and more electron energy levels, which means that because there are an increased number of electron energy levels, there is a weaker attraction from the outer shell electrons to the nucleus, which means that the strength of attraction to attract that electron is going to be much and much harder because the attraction is decreasing because of the number of energy levels. There is more shielding which is taking place. So you can talk about shielding when it comes to halogens because there are more and more electron energy levels. And the nucleus is going to be trying to attract that 1 electron so it's happy and stable and has a full outer energy level, but it's not going to be able to do so because there are more and more electrons, energy levels that are present. So in terms of this question, the reactivity is going to decrease because there are more and more electron energy levels. There is a weaker attraction between the outer shell electrons and the nucleus, and it's going to be more difficult to attract that 1 electron because of the shielding that is taking place. Okay, So if you have a look at the 3 individual marks, again, it's worth putting this into a mark scheme answer and putting into your flashcards and just learning the format of how to answer for these 3 marks. So going down the group, the outer electron shell becomes further from the nucleus. That's what we said. The second mark is coming from, so the nucleus has a weaker attraction from the outer shell electrons. That's what we also said. You could also talk about shielding here, increased shielding between the nucleus and the incoming electron. And the third mark comes by saying an electron is gained less easily. It is harder to gain that electron, so it's stable and has a full outer energy level. Okay, and that's it for this video. Thank you guys for watching. Best of luck with your GCSEs, and I'll see you in the next video.